So this is a continuation of the 2019 problems 4 through 6. If you were watching the previous video, you know I had stopped in the middle of part C, so I'm going to finish that problem now for you. So to remind you, we had three generic functions named f, g, and h, and all three functions were twice differentiable. They told us that g of 2 and h of 2 both have a y value of 4, or is a y value of 4. And we had a line that was tangent to the graph of g and h at x equal to 2. So we had completed part A. We had found the derivative of h at 2. We have done part B. We had done the product rule and the chain rule to find the derivative of a new function introduced as A. And we had done the first part of C. So let me just reintroduce you and remind you of what had happened in part C. So in part C, give me a second here to adjust the paper. They told us to use L'Hopital's rule, or set L'Hopital's rule up in that it applied to the function h, and they had given us the function equal to h, and they wanted us to find f of 2, the y value at 2 for f, and f prime at 2. So what we had done previously is I had used L'Hopital's rule to set the numerator, the limit as x approaches 2 of the numerator equal to 0, and the limit as x approaches 2 of the denominator equal to 0. And if you'll recall, I had shown you how to find f of 2 to be 1 by setting the function equal to 0 and evaluating. So I got f of 2 to be 1. Now I'm going to continue with L'Hopital's rule, which says once you find that 0 over 0 situation, you take the limit as x approaches 2. Now remember, we're finding the limit as x approaches 2 of h of x. That's going to be really important. So the limit as x approaches 2 of the derivative, here's the numerator. The derivative of the numerator is 2x. And here's the denominator. The derivative of 1 is 0. And the derivative in this term is going to be the chain rule. So I have negative 3 f of x to the second power multiplied by the derivative of the inside. There's the chain. And then I'm going to substitute 2 into all the values of x in this expression. Now the important part here is, remember, we're finding the limit as h approaches 2, the limit as x approaches 2 of the function h. Well, we already know that the y value for h at 2 is 4. So that means that the limit has to equal, for continuity's sake, the limit has to equal 4. So that's going to be really, really important. So notice the only thing I have left is to find, or let me substitute 2 in here. That's supposed to be f prime of 2. So I substituted the 2 in for every value of x in the limit, and I know that that limit's going to equal to 4. So then there are several ways I can do the algebra now. I can divide both sides by 4, and that will give me 1 over negative 3 times f prime of 2 equal to 1. So all I did was divide both sides by 4. I can multiply both sides by negative 3, and that will give me 1 over f prime of 2 equal to negative 3, and I can put that over 1. Now, since we have a fraction on the left side equal to a fraction on the right side, the reciprocal of those fractions have to equal each other. So I can take the reciprocal of both sides and say f prime of 2 is negative 1/3, which is what the second part that they had asked me to do. All right, let's look at part D. I'm going to fold my paper over here. So in part D, they tell us it is known that the function g, all the y values of g, are less than all the y values of h. So for the interval on the x values from 1 to 3, that's true. The y values of g are always less than the y values of h. K is another new function, so they've introduced several functions in this problem. And k, all of k's y values stay in between g and h. So, well, let's finish the question. So for this interval, is k continuous at x equal to 2? Justify your answer. Now, the scoring guide talks about using the Squeeze Theorem in this problem, which is not something that in my class we've actually talked about with the squeeze theorem. But I feel fairly confident that you can get away with using the intermediate value theorem to get this, because we're saying right here all of the ky values stay between all of the hy values and all of the gy values. So we have that betweenness. So if this is true, if all the y values of k stay between all the y values of g and h, we can't apply the intermediate value theorem unless k is a function that's continuous on the closed interval. So even though the scoring guide uses the squeeze theorem, I think we can say something like, since g of x is less than or equal to all the y values of k, which are less than all the y values of h, is true, the intermediate value theorem, and we don't have to say the name of the theorem, remember we talked about in that class, the intermediate value theorem applies. Thus, k must be continuous. Sorry about the sloppy handwriting. It's kind of hard not to get my big fat hand in the video. Must be continuous on the closed interval from 1 to 3. Therefore, k is continuous at x equal to 2. So I hope this helps you out with the free response set. Keep studying, keep working, and work hard.